Okay, so your homework, page 4. Here are your answers for page 4. Go ahead and check those real quick. The air conditioner. It keeps turning on and off. I'm gonna try to set it off. Sorry. Okay. You guys can do this. Okay. Any questions from page 4? Yes. Number 12. All right, so for this one here, we have two triangles that are kind of nested inside each other, right? So we have this little guy that sits like this. Its side lengths are 4 and 6. They do share this angle. And then we have the bigger guy who shares that angle. This whole side length here is 9, and this whole side is 13. So we're trying to compare 4 over 9 to 6 over 13. So 4 over 9 is 0.4 repeating. And then 6 over 13 is 0.46. Is that okay? Yep. Other questions? Yes. Number 2. All right, so for number 2, you really don't even have enough information at this point because I only see one angle and I only have one side length. They're not sharing a side length. It doesn't give us any of those values. So the problem is we just don't even have enough to compare.
Oh, so you don't have to make something like another side line.
No, we can't because then you're deciding what those are going to be. So you're forcing it to be something that may not be.
Okay.
Does that make sense?
Yeah.
Okay. Good question. Other questions? Yes.
Number 11.
Yes. So number 11, we're going to look at a lot today. So number 11 has parallel lines, right? When we have parallel lines, don't forget about corresponding angles. We know that corresponding angles are congruent. And they both share this angle up here. So any two of those angles would make an equal angle. Is that okay? We're going to see a lot more of those today. Any other questions? Good. All right, then you had 3 proofs to finish for me. I'm going to check those answers real quick. This is on page 7.
So whenever we do like SAS,
You don't have to put the similarity statement because, or similarity symbol, because the statement actually says similar as well. So because it already says similar, you don't necessarily have to. Most standardized tests will clarify. They'll say side angle side congruency versus side angle side similarity. But you know you do not have to. That's a good question. Actually, you have this packet. I didn't give you this packet before you left. I didn't give you this. Sorry. I had to go through and number their pages because I forgot to number before I copied. Any questions from these 3 proofs?
think 6 times.
Okay, number 6, why is it angle? Good question. All right, so on this one, they give you that EBC and EAD are congruent. Okay, then, so, well, let me write down my given. But then they also, remember, share this triangle, or that angle. So that top little triangle, that EBC, we've marked these two angles. For the bigger triangle, EAD, we've marked those same angles again. So that's why it's angle. Is that okay?
Yeah.
Okay, that's all right. Other questions? All right, so yesterday we focused on determining if triangles are congruent and then proving that, not congruent, sorry, similar, and then proving that they were similar. So today we're going to start the fact that we are having congruent triangles. I keep saying congruent. We are having similar triangles. We are now going to solve for missing parts. Okay, so everything today we're going to work with, they are similar. We're going to be solving for missing parts. So if you can turn to page 8, please. So find page 8, please. All right, so we're going to be using the idea today that if two triangles are in fact similar, then their sides are going to be proportional. What do we know about their angles still? Corresponding angles are congruent, right? Okay, so we're going to work with the fact that the sides are going to be proportional. Now, every time I do one of these problems, I'm going to set up a proportion. I know some of you aren't going to want to do that, and you can do it your own way as long as you're consistently getting it correct. I will set up a proportion because some people confuse themselves if they don't. Okay, so we're really just comparing corresponding parts. I always go left to right. There's no hard and fast rule, but I would compare, for instance, 8 over x to 9 over 27. Some people like to look for what ratio they're in, like they like to look for like a scale factor and do that scale factor. Again, if you want to do it that way and you're consistently correct, go for it. But I will always set up a proportion. So I can cross multiply then, and I'd have 9x equals, that is 216. Divide both sides by 9, and I would have 24. Okay, so we're just comparing the proportional sides and setting up our proportions, okay? We did a little bit of that yesterday in one problem. Okay. Let's look at the next one here. The next one here, I need to compare the corresponding parts. So, for instance, A and 6 are corresponding, and then 8 and 12 are corresponding. So I have A over 6 equals 8 over 12. Again, cross multiply. I have 12A equals 48. Divided by 12, I get 4. In this case, they also ask us to solve for angle B there. Well, angle X. And what did you get? What would it be? 37. Good. But just keep in mind the angles, the corresponding angles, do have to be congruent. Questions on that one? All right, let's look at the last one on that page. They do give you a scale factor on this one, but I'm going to set it up the exact same way. I'm still going to compare my corresponding parts. So my 18 and my 12 are going to go together, and my 3.5 or 13.5 in x. So I have 18 over 12 is equal to 13.5 over x. And I can cross multiply. So 12 times 13.5 gives me 162. If I go side by 18, I get x equals 9. questions on that? All right, so next page is page 9, right? Yes, page 9. Page 9 is going to be part of your homework, but I would like to give you a few minutes to get that part started, and then we're going to move on a little bit. Okay? I'm going to give you about 5 minutes or so to get started. On page 10, we have some more where we're going to be solving for missing parts, but this kind of needs its own explanation. Because what's happening in all of these problems is we really have two triangles, one is nested inside of the other. Okay, there are shortcuts we can use sometimes, and some people figure this out, or it feels natural to them. But then sometimes you don't really understand why the shortcut works, and I want to explain that real quick. So first of all, if we have triangles that are nested inside each other that are similar, it's happening because we have parallel lines. Okay, so when we have parallel lines, those parallel lines actually end up dividing our legs into proportional parts. So I don't have to think about the small triangle, the big triangle. I can just use the parts of the legs that are being broken up. So I can set up 10 over x is equivalent to 8 over 7. So let's do this first, and then I'm going to pull it apart for you. Okay, so let's go ahead and do this. So 10 times 7 is 70. 70 divided by 8 would be 8.75. So that is the shortcut. What's really happening here is I have a little triangle here, and I have the big triangle, the big blue one, right? So if I want to compare sides, like I did, what we just did like the last couple minutes, I would compare the little, the red is x, compared to the big blue one is going to be x over x plus 10, I'm sorry. That'll be equivalent to, we'll go to the red triangle is 7 over 8. Okay, and I can cross multiply here and get 8x equals 7x plus 70.
You mean 7 plus 8?
Yes, I'm sorry, 7 plus 8. I'm like, wait, something's not going well here. Sorry, thank you. Yes, 7 plus 8, the whole blue side is 7 plus 8. I apologize, which is 15. All right, so that looks better. So now when I cross multiply, I end up with 15x equals 7x plus 70. Subtract my 7x, I have 8x equals 70, which looks right back to where we started over there. Divide by 8, and I get my x equals 8.75. So those parallel lines actually cut my my legs into proportional parts. So that is the shortcut. The shortcut does not always work though. Okay? The shortcut does not work when one of the sides are either given or you want to find is a parallel line. Here's why. Think about this 5, the x, the 8, and the 12.5 on the next one. The 5 is an entire side of this triangle. The 8 is only a part. The x is the entire bottom of this top triangle, right? The 12.5 is the entire bottom of the big triangle. So we have to make sure, because we're using a whole side, a whole side, a whole side, this is only a part, we don't have a shortcut we can use. So it's best to think about them then in terms of two different triangles. We have the little guy up top with 5 and x, right? And then we have the larger one that this whole side is 13 and this part is 12.5. So the shortcut only works when you're using the legs that are being divided by the parallel lines. Okay? So then I can set up my proportion just like what we were doing. 5 over 13 equals x over 12.5. Okay, so I'd have 13x equals 62 and a half. Divide both sides by 13, and I have 4.8. all right? How about on problem number 3? On problem number 3, can I use the shortcut? I can't because it's part of the parallel lines. We need the parallel lines, right? So in this one, I have to think about the little triangle and the big triangle. So I don't care if you draw them separately or if you can envision them. If you can envision the two different triangles, then that's fine too. If not, draw them separately. But I would compare x over 16. That's going to be equal to 14 over, I need the whole red side, so that would be 7. I have 17x equals 224. Divide by 17. And I get 13.2. Is that okay? All right, so go to the next page, please. So page 11. What about that first problem? Can I use a shortcut on page 11? I'm sorry, on number 1 on page 11. Yes. How about number 2? Yes. What about number 3? No, because the parallel lines are the parts, right? So that's where we have to use the individual triangles. All right, so your homework is to finish page 9 if you didn't get that done, and do page 11 right here. You don't have to do page 12 unless you really want to, because it's such good, clean fun. Good? All right, so page 9 and page 11.